Okay, so the next part in chapter 5, we're going to talk about a few different gas laws, starting with Boyle's law. So all of these different gas laws relate different properties of a gas. So Boyle's law is the relationship between the pressure and volume of the gas. So I've written the formula here. P1 V1 equals P2 V2. And the subscripts 1 and 2 just represent the initial and final state of the gas. So as long as you have the volume and pressure of a starting point and an ending point, then you can find whichever variable you're missing. So in this example, it says sulfur dioxide, a gas that plays a central role in the formation of acid rain, is found in the exhausts of automobiles and power plants. Consider a 1.53 liter sample of gaseous sulfur dioxide at a pressure of 5.6 times 10 to the third Pascal. If the pressure is changed to 1.5 times 10 to the fourth Pascal at a constant temperature, what will be the new volume of the gas? So constant temperature is important because temperature change also affects the properties of gases. So in this case, because temperature is constant, then the only things that are changing are pressure and volume. So let's start with what we were given in the problem. So we have an initial pressure of 5.6 times 10 to the third Pascal. And then that volume initially is 1.53 liters. Then we have a pressure that it changes to. So that's our P2, and it changes to 1.5 times 10 to the fourth Pascal. So it asks what will be the new volume of the gas. So V2, we don't know. We have to solve for that. So we use our Boyle's law equation, P1 V1 equals P2 V2, and we plug in our known variables. So P1, 5.6 times 10 to the third Pascal times V1, 1.53 liters equals P2 is 1.5 times 10 to the fourth Pascal times V2. So we're going to solve for V2. So the first thing that we need to do to get V2 by itself is divide both sides of our equation by 1.5 times 10 to the fourth Pascal. Okay, so that cancels on that side. So V2 is equal to all of that, 5.6 times 10 to the third Pascal times 1.53 liters divided by 1.5 times 10 to the fourth Pascal. So if we go through and do that math, we find our new volume is equal to 0.57 liters. And our units here, Pascal, cancel because we have Pascal in the numerator and the denominator, so we're just left with liters, and that's how our units work out. So Boyle's law can be used anytime you have a pressure and a volume at a constant temperature, and you are either finding a new pressure or a new volume of a gas.